Good evening. Today we're going to talk about Note 7.1, continuity and one-sided limits, and we are only going to look at these today from a graphical approach in order to give you a preview of what to expect in the rest of the unit. So, we're going to determine one-side limits on a graph and determine if the limit actually exists and what the conditions are for a limit to exist. All right, so the next part's not in your notes, so just kick back and listen for a second. What is a limit? Okay, when we talk about a limit, we're actually talking about the y value that x approaches. So anytime we talk about limit, you basically have to insert the word approaches about 7 kabillion times. So it's not about what things equal, like we talked about the rest of our lives in algebra. It's about what is being approached. So for example, when we see limit notation, first of all, you're always going to see this limit right here. And underneath the limit, we're going to have an x value that's approaching something. Over here, we're going to insert our function. It could be a parabola. It could be a piecewise function. It could be a linear function. It could be any function we've ever studied so far in algebra. So, a couple things are going to happen. This little thing right here means from the left. So, when we talk about this statement right here, this is the limit of the function as x approaches 4 from the left. So as x approaches 4 from the left, what is the y value of the function doing? Okay, so this little thing right here basically means from the left. If you look here, the only difference between the first limit and the second limit is again this symbol here, which basically means from the right. So now we're approaching from the right. So it's the limit of the function. What is the y value approaching as x is coming in from the right? And then last we have the overall limit. If you notice, there's no plus or minus symbol by the 4, and it means that we are looking for the overall limit. And in order for that overall limit to exist, the function must have the same value as it comes in from the left and as it comes in from the right. So what does all this gibberish really mean to you? The best way to do it is just to do a bunch of examples. So if we look, we have a function here, and when I look at this graph, I see a couple things going on. I see that right here at 2, 1, that the point 2 exists at 1. So like if you plug 2 into the equation, we get a y value of 1. So if I look at my statements, I need to remember that this is all about approaching. So when I look at the first statement over here, the question, if you interpret that and take the mathematical notation and determine what is that really saying to you in English, it's really saying as x is coming in to 2 from the left. So we are coming into 2 from the left. So we're traveling up this graph right here from the left, and it wants to know what y value are we approaching. Not what does the y value equal at that point, but what the y value are we getting closer and closer and closer to. And when I look at that picture, I am getting closer and closer and closer to a y value of 2. So then I look at my second statement right here. So right here, I look, and this little plus means I'm approaching from the right. So as I travel into 2, and I get closer and closer and closer to 2 from the right, the y value is also approaching 2. Then the overall limit, when the value from the right and the value from the left are identical, then the overall limit exists at that value. So this one, they're all 2. Beautiful. Okay, let's try another one. Example 1, number 2. Part B, however you want to think of it. All right, so now we're approaching 3. So right down here, here's 3. So this is what I'm approaching every time. My first time I'm approaching from the left. So what is my y value approaching as I come in from the left? So if I come into 3 from the left, so I'm coming in from the left, so I'm traveling up this graph, I look and my y value is approaching 3. It's approaching a y value of 3. Now, what does it equal at that point? What is the y value approaching? As I come in from the right, so now as I come in from the right, I'm coming into 3 from the right, so I'm coming in this direction, so I'm traveling up this graph right here, and as I approach 3 from the right, the y value is approaching 6. So now, if I look, the limit from the left and the limit from the right are different. Therefore, the overall limit does not exist. So in order for that overall limit to exist, the number from the left and the number from the right, the y value has to approach the same thing as you come in from both directions. Okay, example 1, part C, looking at a different graph. So now I'm approaching 4. So if I think about it, I'm approaching this value right here. The first time I'm coming in from the left. So I'm traveling along this graph here, and I need to know what is y approaching as I come in from the left. Well, we're decreasing, and we're getting closer and closer and closer to a y value of 4. When I come in from the right, I'm coming in now from this direction. So when I come in from the right, I'm coming down this graph. And if I look, I'm approaching a y value of 2. As I look at the y value or the limit as we come in from the left and the limit as we come in from the right, they are different. Therefore, the overall limit as x approaches 4 does not exist. Okay, so I want you to take a minute, I want you to hit pause, and I want you to work this out and then rejoin me. All right, welcome back. So let's just talk about this real fast. If I'm doing this, I'm approaching 3 from the left. So here's 3. So as I come in to 3 from the left, this is approaching a y value of 4. As we come in from the right, we are also approaching a y value of 4. And because the limit from the left and the limit from the right are identical, we approach a y value of 4. All right, so the next example is going to take you a little bit longer. So take a minute and look at example 2, number part B, or however we want to think of it, D through N. Hit pause, and I want you to work through this, and then we will see how you do. All right, welcome back. So let's see how you did. I'm going to go through this pretty quick. As x approaches 2 from the right, so as we approach 2 from the right, I'm approaching a y value of, oh, I'm sorry, that says 1. I'm going to put my readers on so I can see better. As we approach 1 from the right, so we're actually approaching 1 from the right, we are approaching a y value of 1, so that's what makes that true. As we approach 0 from the left, so when I come into 0 from the left, I'm coming right along this piece right here, and I am approaching a y value of 0, so that is true. Letter F, when I approach 0 from the left, I am not approaching 1. So when you come in down this little purple stretch right here, you're approaching 0, so we have a false. As we come into 0 from the left and the right, so what you have a piece coming in here and you have a piece coming in here. So if we look coming in from the left and the right, we are approaching 2 different y values, so that's false. And that's why the limit as we approach 0 does not exist, because when we come in from the left and we come in from the right, we are approaching 2 different y values. So letter I, x approaches 0, the limit of the function is not equal to 1, again because we coming in from the left and coming in from the right, we approach 2 different y values. J, now we're looking at 1. So let's look at what happens when we approach 1. So if we look at 1 and we come in from the left and the right, as we come in from the left, we are approaching a y value of 1. So here we're approaching a y value of 1, and when we come in from the right, we're also approaching a y value of 1. So that's what makes this false. Okay, the limit of the function as x approaches 0 is 0. That is also false because we've already established that at 0 the limit does not exist. At 1, coming in from the left right here and coming in from the right, we are approaching the same y value of 1, so that is true. And now if I look at the limit as we approach 2 from the left, so as I come into 2 from the left, so I'm coming in 2 from the left, it appears that I am approaching a y value of 2, so that is true. And even though 4 is not on my graph, if I put a 4 on my graph here, as I come into 4 from the left and from the right, so I'm kind of coming in from the right and the left, I'm approaching this y value here, which I just estimated as 4. All right, hopefully you're starting to get the hang of it, and yes, I get it. It can totally be confusing, and you may have a lot of questions tomorrow. So you're going to be somewhere there on the spectrum of totally understanding versus totally being confused. And some graphs are easier than others. Just remember, don't look at the open circle versus the closed circle because it's what we are approaching. All right, so let's just work through this one together. So we're approaching 1 from the left. So as I come into this graph from the left, I'm approaching this y value of 1. As I come in from the right, I'm approaching this y value of 3. And because the left approaching the limit from the left and the limit from the right, as we approach 1 are different, this limit does not exist. All right. So now I want you to take the last example and I want you to work on that one on your own. And when you're ready, go ahead and hit play again and let's check your answers. All right. So take a minute, look at your answers for this. And if you have any questions over this one, we will address those when you guys get to class tomorrow. Have a great night and I will see you tomorrow in class. Bye-bye.